Okay, let x and y be numbers such that negative y less than x less than y. Which of the following must be true? So one way to do this is to pick values for x and y. And it doesn't say that they necessarily have to be positive or negative or anything. It just has to satisfy this inequality. So let's have y equal 2 and x equal 1. Right? 1 is less than 2, and then if I take the negative of y, that would be negative 2. So it works. Let's test the clauses. So the absolute value of x, which would be the absolute value of 1, is less than 2. That statement is true. We don't know if it must be true, we just know that it's true in this case. So that's why I put the check on the right side, not the left side. The left side is my permanent side. Okay. In fact, it would be nice if I was to get an x at some point, because then I know the x would be permanent, because that means it doesn't have to be true all the time. Does x have to be greater than 0? Does y have to be greater than 0? Well, the test cases that I chose, this is true, okay? But I might be able to find a way to make it not true. So let's try. How about if x equals 0 and y equals 1? Would that work? 0 would less than 1, and this negative 1 would go here. So that's another way to do it. So I learned now that x does not have to be greater than 0. And that x is a permanent x. So now I know 2 is out, so I can eliminate any choices that involve 2. So now the question is, 1 is certainly going to be true, but now I need to know about 3. So is there any way to make y not be greater than 0? Let's find out. First of all, could I have y equal to 0? Well, then I would have 0, 0, so x would have to be 0 as well, but then I would need equal signs here, so that doesn't work. Could I have y be negative? Right? Well, let's see. If y was equal to negative 1, let's say, then I'd have negative 1, here I'd have negative 2, and then here I'd have 1. But the inequality would not hold, this one in particular. So that's, by contradiction, I've shown actually that this does have to be true. Right? I can't find a way to make it negative or 0, so it has to be greater. So I've effectively proven this, so then I can put the check on that side. So the answer is choice C. The scatter plot above shows the relative housing costs and the population density for several large U.S. cities. The line of best fit is also shown, and the equation is this. Which of the following best explains how the number 61... Okay, so 61 is the y-intercept. The y-intercept is also the starting point. Okay? In other words, when our x value equals 0, that's when we have the y-intercept. So with the population of 0, effectively. So that's, yeah, so that's when, let's see. Right, so let's look at the choices. In 2005, the lowest housing cost in the United States was about $61 per month. Well, that's not quite true. It's where the trend line meets, but there's no data point there. In 2005, the lowest housing cost in the United States was about 61% of the highest housing cost. Well, yeah, so these are doing ratios. So, relative housing cost percent of national average. Yeah, so this y value, this height, is a percent of the national average. So it would not be anything in dollars per month, for example. It would be a percent. But again, this one is saying that it was equal to that, but there's no data point there. In 2005, even in cities with low population densities, housing costs were never below 61%. That fact is actually true. So if you think about it, all those data points are above the 61% mark, right, on the y-axis. So I would say C is true. And then this one flips it and makes it at least, let's see, were likely at least. So no, it's not that they were likely. It's not that they were more likely to be above. In fact, they all were above that line. So C is the best choice here. Which of the following is an equivalent form of the function f above, in which the minimum value of f appears as a constant in the equation? So when they talk about minimum value, you should be thinking vertex. And in particular, in the quadratics, we look for vertex form of a quadratic. And so that looks like choice C or D. So we want this thing in vertex form. The easiest way to find the vertex from a factored form, instead of foiling out and then completing the square, right, you can also just find where the roots are, where the zeros are. So we can continue this doing a t-chart. We would get x equals -6 and x equals 4. We just take the opposite values. So if we have roots at -6 and +4, okay, that means that our vertex would be halfway in between those numbers. So we do an average of -6 and 4. So we do -6 plus 4 divided by 2. That's how you do an average. So you get -2 over 2, which is -1. So at x equals -1, that is where our axis of symmetry would be for this parabola. Okay, so we know that if we were to, well, for example, we could also find the y value, but we actually don't have to, because, let's see, our answer would be D, because we can interpret this as being down 25. Okay, this is a vertical shift, and this one is a horizontal shift, because it's inside the parentheses. It's affecting x directly. And this +1, of course, it would be the opposite of what we would normally think. Seeing as it's in parentheses, it's always the opposite direction. So plus we usually think of as to the right, but instead it's actually going to be to the left in this case. So to the left by 1, so normally the vertex would be at 0, 0, and so we have to move to the left by 1, so that gives us a value of -1 for our vertex. And it's the only choice that does that. So choice C, for example, gives +1. If x is the average of m and 9, so the average of m and 9, to get an average we have to add and then divide by the number of items. So the average there is x. And then y is the average of 2m and 15. So we add them and divide by 2, and that gives us y. Now z is going to be the average of 3m and 18. 3m and 18 average is equal to z. What is the average of x, y, and z in terms of m? Okay. So at this point we want to do an average of x, y, and z. So we have to add x, y, and z, divide by 3. Okay. That's going to be our expression that we want. So we would have to do m plus 9 over 2 plus 2m plus 15 over 2 plus 3m plus 18 over 2, and that's going to be all divided by 3, right? So all I did here was I just plugged in the values for x, for y, and for z, right? Now, let's see. First of all, these can all be written with a common denominator, since the denominator is the same for all three. Then I could combine the like terms in the numerator. So m and 2m is 3m, and then another 3m, right? So I'm just going to combine these three together. That gives me 6m. Then I have 9, 15, and 18. So let's see, 18 and 15. So that's 8 and 5 is 13, right? And then this is 3. And then I add 9 to that, and I get 42. So all divided by 3. And I could continue here by factoring out a 3 from the numerator. That leaves me with 2m plus, what's that, 14? Yeah. Then these 3's will cancel. I'll be left with 2m plus 14 as my result. That's choice C.